Okay, so our presentation is called NPOS4 regulates a transcriptional program CA3 required for contextual memory formation, or just how to avoid a bad memory. So before I start, I need to explain three different things to you. So first, what is contextual memory? Contextual memory is basically just forming a memory off of a series of repetitive events. So if, say, every day I went up to Jackson and slapped him in the face at 3 o'clock, every day for like a week, eventually he'd get to the point where he'd realize that come 3 o'clock, I'm going to come and hit him across the face. And normal people would then realize that they don't want to get hit across the face every day, so they would form an idea of how to get past it, and that's kind of what this presentation talks about. The next thing, the basics of contextual memory. They don't really know much about how it works or how it's encoded. All they know is that it uses the hippocampus, which is just a section of the brain. And more specifically, they use the CA3 region of the hippocampus. And again, that's all I really know. It's pretty unknown what's going on there. CA1 is circled, you can see, but I'll come back to that later. So all you need to know is that CA3 is where contextual memory is encoded.
Pause real quick. That was a rat brain, I think.
Yeah.
Looks like a rat brain. So the part of your brain that they're talking about is, I don't know if you guys know where the hypothalamus is, but if you stuck a rod through that part of your head and then right about there, where those two things intersected, actually right about there, where those two things intersected is the hippocampus. It looks kind of like a hearing aid.
Okay, and finally, what is an IEG? So IEG stands for immediate early gene, and you can think of it sort of like a buzzer. So when you have a buzzer, there's the button and the light, and when you hit the button, the light comes on for a quick period of time, like right after you hit the button. An IEG basically is the light, and the cell stimulation is like hitting the button. So as soon as you stimulate a cell, an IEG is expressed immediately afterwards and for a very short period of time. So first, now I'm going to talk about another gene called CFOS, which is not NPOS, obviously. So just bear with me for a second. So CFOS is an IEG that was sort of like scientists' golden standard for neuronal firing. So basically, if CFOS was expressed, then you could be certain that neurons had fired. And as a result of that, they then believed that CFOS regulated expression for a bunch of other IEGs, basically all of them. And so they have NPOS4, and they also think that they just want to track to see that it would also be expressed from CFOS expression. And on the graph, these are just basically different ways of interacting with a neuron. If you look, there's not actually like a common trend of CFOS being higher than the rest of them, which suggests that NPOS4 actually isn't regulated by CFOS expression, which is like a really big thing, because this then disproves the idea that CFOS is kind of like the head gene, and it might suggest sort of like a hierarchy of other genes independent of CFOS. Yeah.
Just for clarification purposes, the NPOS4, the CFOS, they're what you consider to be IEGs, right?
Yeah.
Then what do each of the bottom sections mean? Like, what are those different?
These are basically just like ways of interacting with a neuron, for example.
Okay.
Just show that because things will those things will incur gene expression or anything with them, basically that sort of stuff.
Is Artis to control or?
Yeah, it's just another IEG.
You said CFOS is related to neuron activation. Do you mean action potential firing? Or?
Yeah, neuron firing. I'm sorry. Alright, so now that they see that NPOS isn't actually regulated by CFOS, they wanted to see when it kind of is expressed. So what they did was what's called CFC contextual fear conditioning with mice, and they basically just scared it in the context of like contextual memory, like they shocked its feet over and over again, and then they killed the mice at various times and read the mRNA. And as you can see here, NPOS reaches its peak expression before CFOS and ARC, which suggests in conjunction with the other side that not only does CFOS not express NPOS, but NPOS might actually cause CFOS expression. So this was kind of like blowing their minds here, because they didn't really know they didn't know that this would happen.
Could you say that again? I keep confusing NPOS and CFOS.
Okay, sorry. So NPOS4 is red, and CFOS, which is the blue. So NPOS4 reached its peak levels of mRNA expression before CFOS did, which then suggests that, and of course NPOS4 comes first, meaning maybe that it actually causes expression of CFOS.
And CFOS was the gold standard that everybody thought was doing everything.
Yeah, and so they were just, well. Alright, so after they did that, they did CFC training to see when NPOS4 was actually expressed. So they had 3 different groups. They had the shock, contextual memory, and then contextual memory and shock. So you kind of liken shock like in football, where someone comes and just cleans somebody else's clock, just decks them, but it's like a quick, like sporadic burst or whatever. And then you have contextual memory, which is kind of like Rocky, where he's like doing the speed bag thing where it's over and over, hitting something over and over again. And then you have both groups. You have it both together. In the article, they specified that the shock example, it wasn't actually an example of contextual memory and couldn't actually leave like an imprint on the brain. So it was just more of a control to determine that there would actually be, to determine that there's actual different results between contextual memory and shock.
Wait, the shock doesn't leave a memory?
The shock doesn't leave, it's not a contextual memory, so it won't like do the same thing that those people.
Okay, so is this guy not going to associate shock with, blue and...
Yeah, no, because it's just kind of like quick and it's more like a random like occurrence as opposed to repetitive.
It doesn't happen like at a specific time frequently over.
It just kind of happens randomly and the brain doesn't really know what to do.
I might have missed it, but what's CFC training?
Contextual fear conditioning.
Okay, cool.
So this is the graph of their results. And each one is split up into each gene, and home cage is HC, C plus S, C and S that I just described. And as you can see here, NPOS4 is only expressed in significant amounts in contextual and CS and C, which then suggests that NPOS4 is only involved in contextual memory encoding, whereas CFOS and ARC are involved in all 3, which then suggests that NPOS4 and CFOS are like, CFOS isn't important in memory, or not as important in memory, whereas NPOS4 is only for contextual memory. The next test they did was, they saw that NPOS4 was expressed in contextual memory, but they wanted to know what happened if it was taken out, to see if it was actually necessary or if it just happened to be expressed in contextual memory. So what they did was what's called globally knocking it out. There's 2 types of ways of getting rid of a gene in the brain: global knockout and selective deletion. Global knockout is when you just erase the gene completely from the brain or stop it from working everywhere, whereas selective deletion is stopping it from working in like a certain region or a certain pathway. So in this example, they did global knockout, and WT stands for wild type, which is just regular mice that weren't affected at all, and KO is global knockout. So they did the same contextual fear conditioning. And so what they did to the mice was they took the mice, they put them in a new cage, they let them roam around for 58 seconds, and then after that they would shock them in the feet for 2 seconds, 3 times in a row at a 58-second interval, so that they kind of got the idea not to be shocked, and then eventually they would stop moving because they were too scared. So you see here 5 minutes after the CFC training, they're able to retain some memory that they just got shocked. But if you look at an hour, the number drops down significantly, and an hour is what's considered to be short-term memory. So you can see that the global knockout mice have no ability, or a less ability to remember to be scared. And the same thing goes for the 24 hours. So basically, they see that NPOS4 is necessary for long-term or short-term memory.
Why are there different values at the end? Do they have different mice, like different numbers of mice?
Yeah, you mean like in each 3?
Yeah.
This is like, I think this is just a percentage of mice that like this represents. Because this is a percentage here, I think this is actually the number of mice that goes in there.
How do they do global knockout?
What they did was they insert a gene into the brain, and then it takes 3 days to go through the brain, and eventually it just inhibits NPS4. As like I know I said knockout, it doesn't like actually like remove it, it just stop it from working.
I'm sorry, I think I missed it. What does WT stand for again?
Wild type, so basically just the mice that were knocked out.
Oh, okay.
The next thing they wanted to know was, is all NPS4 necessary? And when they looked at the genetic path, when they looked at when NPS4 was expressed in contextual memory, they saw that it was expressed mainly in the CA3 region, but also in small sections in the CA1 region. So they wanted to know if each one individually was necessary or if both together were necessary for long-term or short-term memory. So they did the same thing, same global knockout, same CFC, and then they killed the mice again and read their brains. And this is an hour after CFC training, so again, short-term memory. And so basically you see that the numbers are all around the same. I mean, obviously there's a little bit less here and there, but the gist is that CA3, oh, I apologize. This is CA3 knockout, this is CA1 knockout, and this is just wild type again. So in the red you can see that CA3 is not really necessary for short-term memory, and neither is CA1. But if you look at the 24-hour over here, you see the significant dropout, which then suggests that CA3 is necessary for long-term memory, whereas CA1 again isn't really. After that, they did one last test. They wanted to see if it was possible to restore the deficit of memory. So what they did was they injected, they had the same 3 groups, except this time they had a fourth one. And they added NPOS4 to all 3 knockouts again. But the third one, they injected an inactive version, so basically it wouldn't express. So they wanted to see if NPOS4 just needs to be present or if it actually needs to be expressed for memory to be encoded. So after they did that, you can see that 1 hour afterwards, only the CA3 region active NPOS4, and 24 hours the same thing. So basically it's saying that you need to have NPOS4 expressed in the brain in order for you to be able to either restore memory or encode it.
Percent freezing measures, what is that?
Percent freezing, that's like how they measured the mice actually remembering to be scared, because they would shock their feet, and if they remembered, they would. Freezing means like just freezing movement, so they'd stop moving. Yeah, like I thought that too.
Can you go back a second?
This one?
Yeah, so here you have knockout. Okay, no, so CA3. Never mind, you're good.
Okay.
Why is there like a drop for CA1? Like it says that it's significant, but why would the CA1 be significant if you said it has no role?
It didn't specify that. All I really talked about is that it's important for CA3. I'm not entirely sure.
To answer that question, I think it's more like when they tried putting NPOS4 back into the CA1 region but not the CA3 region, nothing really happened. Nothing really changed.
Yeah.
I think his point is that it looks like something happened.
Well, no, because it's already low, right?
Yeah.
Because they had already removed it. This is putting it back in to see if it improves the situation, but it didn't, which just reinforces the fact that CA1 is not as important as CA3.
Right.
Yeah.
Gotcha.
So it's
also
like saying
explains why the knocked out CA3, the non-function.
Oh, would not go, yeah.
Yeah, I mean, just,
What else? Nope. Okay.
Jackson.
Oh, yeah?
Did they put the inactive form of NPS4 in the third or the fourth?
In the fourth, it's the one with the little delta sign right there.
Okay.
Okay, so basically just to conclude what I said. So acute deletion of NPS4 so in certain regions results in long-term memory loss. Only the NPOS4 in the CA3 region is necessary for long-term memory encoding. They found out that NPOS4 is not only not regulated by CFOS, but might actually regulate CFOS and other IEGs, which then suggests like a higher rate of other IEG and gene expression, which NPOS is at the top. They saw that introducing NPOS back into the brain results in memory loss or memory deficit restoration, and they hope to like further understand what's going on in the brain from this presentation.
Did you say that deleting NPAS4 actually deletes long-term memories, or does it prevent the encoding of new?
Yeah, I say it results in the loss of long-term memory. I apologize. I mean, like, you can't encode for long-term.
Okay, there's no forming of new ones.
Yeah, so.
So this won't help with like PTSD.
Wait,
It's written on the board.
Yeah, it is.
Now, do we have these AEGs at the as well? So there's some-
No, we have them too. Same spots too. Okay, so kind of going on what Amol was saying, when soldiers like get deployed and they come back from war, they have like post-traumatic stress disorder, and it's based off of like contextual memory, and they're scared, and certain things can like send them on a trip, like a mental trip. So do you think that if you were a soldier, you would want to be offered the opportunity to get like a procedure to remove NPAS for you, so you don't have to worry about developing something like PTSD?
Well, would this be before or after?
Before.
You talked about long-term memories over an hour, or was that short-term?
Short-term memory is 24, or long-term is 24 hours.
Over.
But this would not just affect, bad memories. This would also affect like instructions and things like that, right?
Yeah.
So
No.
So, yeah.
Forget everything
you don't have to be given all the information at the same time. For example, you could be given instructions on what to do before the drug was administered. Just throwing it out.
after it's already launched.
No way.
Like in my presentation, it was about PTSD, and like sort of like an implication was like later on if they forget something that happened, like I guess during the war that was important, like and they can't remember it, but they need it for like government reasons, like that might be an issue. So like if they forget important details and stuff.
Louder, Harrison.
If there are less repercussions, I mean, everyone thinks of war as this terrible thing, partly because of PTSD. If you get rid of PTSD, will people get morally, against war?
So here's a crazy thought. Effectively for you guys, for us as humans, if there's no memory of an event, it didn't happen. So for example, anesthesia, right, is coupled with, oftentimes with memory, things that impede. So it's not that you don't feel the pain, it's that you don't remember that you felt the pain ever. And so essentially, it didn't happen. You have no memory of being hurt, you have no memory of, anything traumatic happening to you at all.
Wouldn't that be scary if you were hurt though, and you come back from war and you can't remember how you were?
Well, this is what happens, right? So this is what happens when you're not able to form contextual memories, like if you get knocked in a car accident or something.
So this is like a form of sort of creating amnesia before that.
Yeah.
Is this similar to short-term memory loss?
It didn't specify that. I mean, I would suggest maybe, but I mean, like there's other ways of forming long-term and short-term memory besides like contextual memory events. So, I mean, it might result in short-term memory loss and things like learning in the classroom and stuff like that, but other things, I don't know.
Well, here's another way of looking at this. So if, putting NPAS4 back in the CA3 region helped solve some of the memory deficit, would sticking this protein in people who are unable to form long-term memories, would that actually lead to some sort of benefit?
It might, I'm guessing, but I think you have to first specify that the problem was in the same. Because I was thinking the same thing, like, could you use it for like disease where you can't remember things, but then I thought you don't always know where the problem is. But I think, maybe it's possible at this point to restore memory loss.
So if this drug only has things as roles in playing in contextual memory, correct?
Yeah.
Primarily, at least. So then, wouldn't that be kind of ineffective, giving it to soldiers, because in order for them to form contextual memory, something has to be repeated, there has to be a pattern,
Gunshots are.
for example.
Multiple final
But
hits.
again, if you have short-term memory is short-term, as I believe you mentioned, it was about an hour. So unless something gets repeated at least as many times as needed to make it into a pattern within an hour, this won't have any effect.
And this is assuming the drug lasts longer
No, but
than an
that's-
hour.
That's true.
That is how like PTSD is created with like the multiple rapes, the multiple like fire attacks, like the contextual memory of that. Kind
Eventually your brain will like catch on.
of, yeah.
If an event is traumatic enough, you can still form contextual, like it doesn't have to be repeated. If it's like dramatic enough, then that one thing will set it off again.
Yeah, and don't forget that there's other ways of doing this, right? So, I mean, while it would explain a lot of your behavior, if something happens once during short-term memory, it can be committed to memory. That was an insult.
No, it wasn't.
No, it-
I didn't understand.
Say that again.
No, the moment's gone.
Wasn't a very good insult.
You're not a very good insult.
Okay.
Isn't that a compliment though? That is not a very good insult.
Okay, it doesn't.
Yeah.
No, it means that you guys don't remember anything that happens to you.
So why is
That's not an insult.
What did you say? I don't know.
Is that
We know that's true, Sweetie.
Is that
I think he's going.
Yeah, he is.
I mean, we'll be happy.
You're gonna be in class later.
Yeah, I know.
All right. Where's the other one? Oh. Okay. Thank you very much to Jeff. Next week is Sydney Stryker with muscle formation. Where's Sydney? I believe it's muscle formation. Will Johnson please stick after? And I'm sorry, but IRT next Wednesday. I'm going to try to get us a meeting scheduled during Headmasters, but if I can't, it's going to have to be in the morning. Just to discuss IRT week.
Next Thursday, if we have APs, or excused.
Oh, yeah, let me figure that out. Let me try to get a time. Peace, thank you.
Good job, guys.